So if you guys remember, vectors are based off of two things. They're based off of a direction. No. And they're based off of magnitude. So they have two things. They have a direction and they have a magnitude. Now, yesterday when we were talking about the direction, they could say something like find the component form of the vector, and most of us liked it when they phrased it that way, but they could also say find the direction of the vector, and the answer was the same. It didn't matter how they asked it, it was the same answer. So give yourself some space here, and then remind yourself that this is what the component form meant, so we'd have like a number and then a number, and that the direction of the vector was the horizontal component as well as the vertical component. So the direction that a vector is going is how far to left and right it goes, how far up and down it goes. Now, if the word problem says a plane is heading 32 degrees west of north, then what do you think the direction is going to be for a word problem? What type of thing are we going to look at? The angle, right? The degree measure? Does that make sense? You guys are like, awkward. It's the degree measure. So for us, we're not going to be looking for a point anymore. They're not going to give us an actual x value and an actual y value. We're going to be looking at a degree measure, because if we know what angle it's flying at, then we know what direction it's going. All right, so that would be the most similar to direction. Do you guys remember what the magnitude was of a vector? But for what we did yesterday, what the magnitude was? It was square roots and stuff, but what did it actually mean for the vector? So this tells you that it's going left and right and up and down, and the magnitude was the length. So when we talk about story problems, we're going to say the plane was flying 32 degrees west of north at a speed of 536 miles per hour. That 536 miles per hour tells us how long that vector should be because it flew in that direction for a certain period of time. Does that make sense? So magnitude for us is going to be speed, because that speed is going to tell us what the length of the vector is. It tells you how long you're doing that. Okay. So what we need to do is we need to take this information, this degree measure and this speed, and we need to figure out somehow where we can combine these two things and get a component form that reflects both of them so that the vector has not only a direction but also a speed, and it's combined so that we have the whole vector. So we're going to bring back the unit circle. Are you guys excited? Woo! Yeah, I'm just going to draw a little sketch. Does anyone remember what the radius of the unit circle is? It's a radius of 1. I'm going to go ahead and label that that's 1. So what I'm doing right now is I'm drawing a vector. I'm drawing a vector in the unit circle. So if I am drawing a vector in the unit circle, what is the length of my vector? 1. So what I just drew was a unit vector. Okay? And if I want to figure out how to write this unit vector in component form, then I have to write down the horizontal component and I have to write down the vertical component, right? And so I could think of this kind of like saying that this would go over however far x is and then up however far y is. Would you guys agree with that? Over x amount, up y amount. So I can say that my component form is x comma y. But we, in the past, we've talked about our x's and y's in terms of like sine and cosine and tangent and all of that. So how could I rewrite x in terms of sine or cosine or tangent? Do you guys remember which one corresponded to x? It was cosine. So if I say cos theta, if I know that what the degree measure is, then cos theta would correspond to that horizontal component, because it's how far to the right you would go. And then what would correspond to that vertical component? Sine theta. So if we know an angle that a plane is flying, we can describe that direction the plane is going, but when we describe it using only the degree measure, we're going to get a vector that's a unit vector. So it's going to be in the correct direction, it's just not going to be long enough, because it's not going to represent any speed, it's just going to represent what direction the plane is flying. So if we look at the first story problem that we're about to do, we're going to do a plane is heading 32 degrees west of north. And these problems are calculator problems, so that means that our numbers have to be in standard position so that we can plug them into the calculator. So what should I do with this to make sure I know what it is in standard position? Yeah, I'm going to draw a little sketch of it and make sure I know where it's at. So north is up here. 32 degrees to the west of that would be like this. So there's 32 degrees to the west. And so if I was to write down what my standard position is, what would that angle be? Yeah, it'd be 90 plus 32, which is 122. Okay. So if we were to write the unit vector for the plane, not taking its speed into consideration, just what direction it's heading, we would say that it is cos 122, sine 122. Or if you want to write it in the AI plus BJ form, then you can write it like this. And I think when I did the assignment, all of my notes has AI and BJ form, but it doesn't matter because they're the same. So it's up to you. If you want to write it in component form, you're welcome to. Okay. Are we good so far? That part makes sense? Okay. Now at this point, if I want to take this plane and then show, so this vector, and I want to add some length to it, I know the length shouldn't be 1. I'm saying the speed of my plane is 536, so the length of my plane, of my vector, should be 536. So what do you guys think I could do to reflect that this vector is getting longer? How could I make it look longer? If you want to take something that is 1 and make it a length of 536, what could you do to that 1? Multiply it, right? So what we're going to do is we're going to take this vector right here, and if we want to add the speed of 536 miles per hour, then that means I'm going to take my vector, so that cos 122i plus sine 122j, and in front of that I'm going to put that magnitude right there, and I'll distribute it, and then once I'm done distributing that, now I have a vector that has the correct length. So now I've got a vector that has the magnitude and the speed. Both of those are involved. Oh yeah. Sorry, I didn't mean to write 112. I wrote 112, but it was 122. Sorry. Okay. So that would be the vector that represents the speed and the direction. That's all you have to do.